So there's quite a few authentication protocols that are used in modern networks when dealing with access control and specifically to networks. One of them is this thing called PAP, Password Authentication Protocol. Very limitedly used. I mean, I haven't seen this in a long time, but this was one of the first ones that was used. Super susceptible because it sends stuff in clear text. One of the examples that we put in here is the movie War Game. Maybe you've heard of that before. There was the password authentication protocol was very early on. And then it kind of built on top of there. There's a Shiva password authentication protocol that came in and replaced PAP. It started to encrypt the username and password, but it still was susceptible to the man-in-the-middle attacks. Whereas another one came out that was called the Challenge Handshake Authentication Protocol, and it was deliberately because of the last one, the SPAP, being susceptible for man-in-the-middle attacks. And it went like this right here. So, the user would initiate the login request, the challenge would come back from the server, and then another challenge would then be generated on the server. The person would have a client over here on their side that would have a synchronous token that allows them a session ID, and that hash between these temporal tokens, is sent over, and it needs to match what you had over on your laptop or whatever device to what the server was expecting you to provide. And at that point, it was either a decision that you're in or you're not in. So it's just a Boolean value, whether or not you're in or out of it. So at a super high level, the CHAP was used to really make that remote authentication much easier to protect than previously. And it was so good that, wouldn't you know it, Microsoft came around and said, hey, we like that idea so much that we're going to go ahead and call it our own. And what they did is they took whatever the Challenge Handshake Authentication Protocol was using, and they said, you know what, we're going to go ahead and make our own. And so they came one that was used the Microsoft built-in NTLM landman hash, and then they made another one that was for non-Microsoft passwords. But when they built these in, the idea is that the server would challenge whoever's trying to remotely connect, and that challenge then became what is commonly known in our industry as a nonce, or a random value that gets generated. And Microsoft still uses MS-CHAP. So next one, it gets a little bit more complicated, but hopefully it's not too complicated where it doesn't make sense. But there is this hashing algorithm that is generated this one-time pad or one-time password, and it's a counter that we call the hash-based method authentication protocol. And it deals out what's called a one-time password. In this particular case, the HBAC, which is the hashing method authentication code, allows the two-factor authentication by the user has a secret key, and that's something you know, and then the seed counter is something you have. So give me an example of this one right here. What does this kind of look like? We have something that counts over here. ATM card? I don't know. Card. Yes, that's what I was thinking, Brian. The RSA Secure ID, and yeah, a multi-factor. Yeah, an authenticator app. That's exactly right. Authenticator app as well. Where it generates a one-time password, and then it gives you some sort of 60 seconds to put it in, or however long to put it in. And is it what the server is expecting? And so this is called the HOTP. HOTP. Whereas this one, so this uses counters specifically, the hash-based. This one uses a time-based message authentication protocol and a one-time password, which is very similar to the previous one, except the seed counter here is time. So it like timestamps it and gives you a one-time password, as well as some sort of expiry period that you have to use it for. So that's the TOTP. Both of those are different types of one-time passwords. And then the last one here is this Kerberos. And remember, anytime you're going to see Kerberos on the exam, and you will have probably one on your exam, it's going to be tickets, 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 tickets. And so what happens is the client will request a ticket granting ticket, or ticket to get tickets. And then the ticket from the key distribution center will be sent back to the client encrypted. The client will then return the unencrypted ticket to get tickets, and then the authentication server and the ticket granting service will then give a ticket back to the client. The client then has however long the ticket is good for to access whatever resource or object within the network, like an application server or maybe a switch or router. And so they present that ticket, they're challenged, and then they get access to it. And so Kerberos usually is tickets, and it typically will run over port 88.